You have it written down on the key items. What is a scale factor? The number you multiply by all the sides to get the other side. Okay, you can come see me after class for a homework pass. So, find the scale factor. There was a number multiplied by 4.5 to get 6. In order to find that, you make a fraction. You put 6 over 4.5. What is 6 over 4.5 reduced to? 4 over 3. So that is the scale factor. It doesn't matter if you did those two sides. If I chose to use 6, what side on the other triangle would I use? 8. And 6 over 8 reduces to 4/3. Still. Alright. Oh, sorry. 8 over. Sorry. I wrote it wrong. 8 over 6 reduces to 4/3. And again, if you did 9 over 6.75, it reduces to 4/3. So, why does the scale factor, if I'm going from the left to the right, have to be 4/3 and not 3/4? Because it needs to get bigger, right? Is 4/3 less than 1 or more than 1? It's more than 1. It's 1 1/3. So, if you're going from a big to a smaller polygon, you're going to have less than 1. But if you're going, like in this picture, a small to a larger, it has to be bigger than 1. All right? So that's the first portion. We found the scale factor. The next thing is list the pairs of congruent angles. Do you even need to look at the picture to list the pairs of congruent angles? No. What can I look at instead? What is this called?
Simple.
The what? Nope.
Format?
Nope. It's also on your paper. The similarity statement. Thank you. You can come see me after class for a homework pass. Similarity statement. So, starting with angle A. What is angle A congruent with? Angle L. Angle B is congruent with angle M. Angle C is congruent with angle N. Alright, and then the last, so we have congruent angles written. We need to find the ratios of the corresponding side lengths. What is a ratio in general? A fraction. So what does a statement of proportionality look like? Fractions. How many fractions will we use? 3. Why do we choose 3? That's the number of sides. If you have a quadrilateral on your quiz, you need to have 4 sides, so 4 fractions. Here's a triangle. Do we use the numbers or the letters to write a statement? Letters. So, start with AC. What does AC correspond with on the second?
LN.
LN. So we got those two. All right, what about CB? NM. And then last, AB. LM. So there are 3 parts to the scale factor. That's one. Congruent angles, that's the other. And the third is a statement of proportionality. All right, any questions on this? Okay. All right, the second thing is decide if the polygons are similar. We're still reviewing from last week. We're still reviewing from yesterday. For those of you who don't see yet, but this paper that was on your desk, these are literally all of the slides. So you don't need another sheet of paper. Yep, that. See how that works? So, deciding if these polygons are similar, 2 things have to happen. The corresponding angles have to be congruent. So the first thing you need to check, on triangle A, it's called, there's angle L. Is there an angle on triangle B that it's congruent with?
Yeah.
Yes, which one?
R.
R. So we got those 2. That's good. What about J? Is it congruent to another angle?
Yes.
P. And then K. Q. So are all of the angles congruent to another angle? Yes, so that's good. Next thing, corresponding sides have to have the same scale factor. So it doesn't ask, find the scale factor of the smaller to the larger or larger to the smaller. It just asks if it has the same scale factor. So me personally, I'm going to put the side from angle A or triangle A on the top and the sides from triangle B on the bottom. So what I mean, start with 40. What angle or what side corresponds with
28.
40?
32.
32. Reason being, 40 is between 2 and 3 curve marks, so is 32. What is 40 over 32 reduced to?
5
Over 4. Yeah. All right, so all of them should be able to reduce to 5/4. Then next I would do 30. What does 30 correspond with?
Can I get Kylie Crawford's escalating office?
Yes, ma'am.
Maybe.
What does 30, focus, what does 30 correspond with on the second triangle? 24. What does that reduce to?
5/4.
5/4. And then the last we need to check.
35 over 28.
Yep, 35 over the last one, which is 28. Reduce, they're both divisible by 7, so 5/4. Do they all have the same scale factor? Yes. Okay? Yes, they do. So are these similar? Yes. So. All right, so we are going to go into this. These are perimeters of similar polygons. So this is the next page. I'm going to write a formula that's not necessarily written on your paper because you're going to have no clue what their formula means. Here is the theorem. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So this is the technical formula. Does it make sense to you?
No.
Probably not. So I'm going to write another one, and I want you to write it down. Okay, so you're going to have two fractions. Before I tell you this, what is a perimeter in general? The distance of the outside. So whenever you think of perimeter, you want to think of like a fence, a wall. Yes, it goes on that slide, this one. So the perimeter, in order to find a perimeter, you add up all the sides. Okay, that's why they wrote PQ plus QR plus RS plus SP. That's the perimeter of the red. And then KL, LM, MN, NK. Those are all the perimeter of the blue. So what you're going to do is you're going to find the perimeter. So you're writing this in yours. Of the first shape. You're going to put it over the perimeter of the second shape. That's your first fraction. So the perimeter of the first over the perimeter of the second. All right, then you're going to put a side of the first over a side of the second. And the two sides have to be corresponding. Corresponding. Okay, so this is the general formula. Perimeter of the first over the perimeter of the second. A side of the first over a side of the second. Okay? And they have to be corresponding. So what that means, what side of the second shape does KN correspond with? PS. So KN over PS is acceptable. Things like that. Okay? So they have to be corresponding. So we are going to do this problem first. The two gazebos shown are similar pentagons. Find the perimeter of gazebo A. Does everyone know what a gazebo is?
Yes, it's those buildings.
It's like a wooden,
Andre don't know.
you sit under it. It's got like a bench. Most of the time it's circular. I've never seen a pentagon. You've no one. Are you kidding?
I know what they are. Gazebo.
They look like this. They're like circular.
We heard you.
They have like poles sticking out. I don't know. You can just Google it. Anyways, it does not look like a tent. Tents look like this.
Hey, we don't need demonstrations.
So not really. Okay, so back to this. Even if you don't know, focus. Even if you don't know what a gazebo is, focus. Even if you don't know what a gazebo is, so face forward. Face forward. Think legs under the desk. Both of them. Okay. Well, it's better than facing Lucius the whole time. The two gazebos shown are similar pentagons. Find the perimeter of gazebo A. So you're going to use the formula. So perimeter of the first over the perimeter of the second equals a side of the first over a side of the second. So, do you know the perimeter of the first shape? No. How would you find the perimeter? You would add up all the sides, but you only have one side. So you don't know that. So guess what? That's what we're going to end up looking for because that's what it says. Find the perimeter of gazebo A. Can we find the perimeter of gazebo B?
Yes.
Do it yourself. Go.
We do it on.
You can do it on your paper. Oh, shoot. All right, so add up all the sides of the second gazebo. What does the perimeter? Meters. All right, so now we fill into our formula. It's not squared, only area is squared. What is the perimeter of the first? Do we know it? You can call it X. I prefer to call it P. Here's why. We're about to do area, and it's a very similar formula, so it's just kind of like an extra help at the end to know what your answer is. An area, you would have a squared unit, yes. So, what is the perimeter of the second object? 69. Yes, you do. You just added them. All right, and then it says a side of the first over a side of the second. What is the only side you're given? 10. So you have to use the side it corresponds with in the second pentagon. So which side would that be? 15. So you're going to do 10 over 15. When you have one proportion set up equal to another, how do you solve that? Cross multiply. So you'll have 15p equals 690. Divide by 15. What does P equal? 46, and it is meters. That's all you do. So you set up a proportion with the two perimeters and with two sides, and then that's it. Any questions?
Nope.
Okay. Go to this page if you're not already on it. I chose this because it's similar to problems that you're going to be doing in your textbook, also to one that you're going to do on your quiz. Two polygons are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. So, here's where you're going to have to use your common sense a little bit. In the first one, we're given the perimeter of a smaller polygon. So, you can just draw a little box. Just visualizing this. So, if there's a smaller polygon, obviously there's going to be a bigger polygon. What is the perimeter measure of the smaller polygon? 12 feet. We need to find the measure of the larger polygon. Okay, or the perimeter of the larger polygon. Whenever you have the scale factor, what does the scale factor do to the sides? Does it add, subtract, multiply, divide? It multiplies. But think about this. If you multiply 12 by 3/4, does that make the number smaller or bigger? Smaller. But are we finding a smaller polygon or are we finding a bigger one? Finding a bigger one. So what are we going to multiply by? 4 over 3. 3 goes into 12 4 times. 4 times 4 is 16. So you should get 16 feet. All I did was multiply. Questions about that one? Okay. The second, are we given the smaller or the larger? The larger. We got a larger one and a smaller one. The perimeter of the larger is 72 inches. It's the same thing as 6 feet. The scale factor is 6/5. So again, if we go to multiply, if I multiply by 6/5, is that going to make the objects bigger or smaller? It's going to make it bigger. Do we want to make it bigger? make it smaller, so we need to do 5/6 instead. 6 goes into 72 12 times. 12 times 5 is 60. So 60 inches. So it really isn't that much smaller. Questions on this section? Okay. Our word problem. A town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. So I'm pretty sure you guys already have the drawing. Am I right?
Yes.
Okay. The new pool will be similar in shape, so it will also be a rectangle, but will have a length of 40 meters. Do you already have that?
Yes.
See, I don't have that, so I have to draw it. So it will be similar, but instead of 50 meters, it's going to be 40 meters. So 40 meters. Find the perimeters of an Olympic pool and the new pool. So first off, we can find the perimeter of this Olympic pool. All right, this is a rectangle. To find the perimeter, you add the sides. A lot of you would think that it's 75. Is the perimeter 75? No, it is not. 25 is on the left side, which makes it on the right side. 50 is on the bottom, which makes it also on the top. Yes, you add them all up and you get 150 meters. All right. Do you know the perimeter of the second?
No.
No, we don't. Do we know a formula or something like that to help us figure out the perimeter? Yeah. We need to set up a proportion using the scale factor. So I gave you the formula. What went on the top of the fraction? P, but the perimeter of the first. Do you know the perimeter of the first? 150. What goes on the bottom? Perimeter of the second, which here would be P. All right, equals a side of the first over a side of the second. Yeah, you would use 50 and 40. Why couldn't I use 25? Yeah, you don't have the width of the other pool, so you can only use 50 and 40. Could I have flipped it and done 40 over 50? The numerators have to be from the same pool. So 150 and 50 come from the top pool. P and 40 come from the bottom pool. After this, we're going to cross multiply. 150 times 40 is 6,000. P times 50 is 50p. Divide by 50, you get 120. So 120 meters. So the first pool is 150, because it asks to find both. First pool is 150 meters, the second pool is 120 meters. Any questions on how we found this one? Okay. You guys are going to do the one on the next page. Doesn't have a picture, but you guys are going to do it. So your neighbor has decided to enlarge his garden. The garden is rectangular with 6 feet, or with a width of 6 feet and a length of 15. All right, so what perimeter would that be? 42, because there's a 6 over here and a 15 over here. Add them all up. That's 42. So that was like half the answer right there, because it said find the perimeter of the original and the enlarged garden. So the new one will be similar in shape, so it will also be a rectangle, but it will have a length of 35. Find the perimeter. So we don't know the perimeter. So you set up a proportion. What is the perimeter of the first garden? 42 over the perimeter of the second. Do we know it? No. So we call it P. All right, and what side would we use of the first garden? 15 over 35. Cross multiply, you get 15p. Is it 1470? Divide by 15. P equals 98, and it is feet. All right, how many of you got 98 feet? Good. Did you get it, Mr. Messer?
Yeah.
Good job. Okay, so now we're going to move on into area. It's a very similar formula, but it's a little different. What kind of answer do area problems have? Squared. So inches squared, meters squared. So it's going to be very similar. I'm going to show you what the actual formula is. And then I'm going to show you what I would like you to write down to make it a little bit easier on your life. So it's very similar to the first formula. You're going to put the area of the first over the area of the second. Alright, and then the side of the first over the side of the second. Sorry, it does not look like an E. Alright, but it's squared. That's the only difference between the two formulas. Reason being, the area is already squared. It's in square units. But our sides are not in square units, so use square. Okay? So this is the formula that you will want to know. It's not in a textbook anywhere, so if you have not written it down, your life's going to be hard. Alright, so we are going to do these two problems. We have this problem and then one more. In the diagram, triangle ABC is similar to triangle DEF. Find the area of triangle DEF. Alright, so just like we did with perimeter, the area of the first shape goes on top. What is the area of the first? 36. You don't square it. It's already squared. Alright, do we know the area of the second? No, so you write A. This is where I write A instead of P, and this is why I don't write X's. It's not necessarily wrong, it just helps me not get it incorrect at the end. Alright, so then we do the same thing that we did before when plugging it in, but we have to make sure that we end up squaring what we're doing. Alright, so what side comes from the first shape? 10. And what side comes from the second? 5. Alright, so we have 36 over A. When something's being squared, what is really happening? It's being multiplied by itself. So this is really the same thing as 10 over 5 times 10 over 5. 10 times 10 is 100. 5 times 5 is 25. Do not reduce it because this is a proportion. We're just going to use the proportion. Cross multiply and you get 100A. 36 times 25, isn't it 900? It is. So divide by 100. And the area equals 9. Then we use our units. It is in centimeters squared. That's it. So same formula. The only thing is you have to square the second fraction. Questions, comments, concerns? Okay. And then we're going to do the last one, which are rectangles. I think they're on the same page. Am I right? Yeah. So we're going to set up the same two fractions. What is the area of the first? 84. Do we know the area of the second? No, so we're going to put A. What is the side from the first shape? 7. What's the side from the second? 21. Alright, so we'll have 84 over A. We're going to leave those guys alone. 7 squared is 49. 221 squared is 441. I said 221. Alright, cross multiply. 49A equals this number I do not remember.
756.
No. One before that.
37,000.
44. Divide by 49. The area equals 756. We are in meters squared. Looks like a crazy answer, but look how much larger this rectangle is. If this one was 84 meters, this one could surely be 756. So from here,